All right, up next, we have Arlind Dervishaj, and he's joining us from Arco Architecture Company, where he is an architect as well as a digital daylighting and sustainability expert. Arlind's work is delving into the investigation of the intersections of architecture, this phrase that he calls regenerative sustainability, which I think is a wonderful phrase, then the use of building information modeling and data-driven workflows, again, all with the idea of supporting early and evolved stage designs for improved daylighting. So without further ado, welcome Arlind.
For the introduction and VELUX for inviting me. My presentation today will be on daylight for regeneration at both urban and architectural scales, also in relation to the European daylight standard. And initially, I will make a brief introduction of who we are and also also try to answer what is the role of daylight in this new paradigm of sustainability called regeneration. So we are Arco Architecture Company. It's a new established firm in Helsinki, Finland, from the merger of 3 firms. And we are bringing together around 200 experts in building design, landscape, and other fields. And we have completed demanding hybrid projects, shopping centers, hospitality, education, residential, and so on. And also equality and supportive culture are part of our driving values. So why sustainability is not enough? In this diagram, I wanted to show how conventional practice really sets the minimum requirements that we need to comply with. And then green building standards are mostly trying to reduce environmental impacts and increase systems efficiency. And sustainable design at its best, or net zero, net carbon, is just being less bad. So just trying to reduce and not doing anything more. But we actually need to do more good. And so the next step is restorative, reconnecting with places, with nature, have a sense of belonging. And when we think of nature-based solutions, or when we think of trying to limit climate change to 1.5 degrees, we can think of as the first steps towards regeneration, towards having a positive influence in planetary boundaries, not degenerating, but regenerating them. And regeneration actually means sustaining life itself. So after 10 years, a new development may come that may undo the good. So we need to be part of nature and be part of this web of life that we are all connected. In terms of building design, it means designing buildings that with healthy and clean materials for people and the planet, non-toxic, and also try to make these elements go back to technical or biological nutrient flows. And this is not only a technical problem, it's also a cultural shift that we need to do. And also the new European Bauhaus can be an opportunity. So it requires whole systems and living systems thinking. But how can this new paradigm of sustainability, of regeneration, can be in digital practice? So a lot of approaches are not new, like bioclimatic design, or indoor comfort, or outdoor microclimate. But we need a more holistic way, and we need to include this in our practice. And that's what we're trying to do. And also biophilia, landscape, health and well-being strategies that need to come from the early design. Embodied carbon, environmental analysis, so work with the forces that shape the place, shadows, sunlight, wind, and so on. And natural and artificial light, both we need to consider when designing. So when designing with daylight metrics, we've had minimum sunlight hours in the Athens Charter of Le Corbusier. We've had the daylight factor for over a century. And in the last decade, we've had growing use and also in standards and regulations, climate-based metrics. And in the future, we expect maybe to have better understanding, better tools to design for circadian lighting design, better beam and integrated analysis, much more use of optimization methods, and also machine learning. So it is becoming much more demanding, but also much more interesting. And we know that we spend 90% of the time indoors, and the famous quote of Churchill, that we shape our buildings and afterwards they shape us. And there's also history when the House of Commons was to be rebuilt. And it was decided to rebuild it in the previous shape, rectangular, and not go in a new shape, oval, horseshoe, because that's how British democracy was shaped. And also the transition for healthy buildings, I believe, is being sped up by the COVID pandemic, that we are hopefully going out. And the Human Rights Council just a month ago declared that a clean and healthy environment should be a human right. So when it comes to the urban scale, we can design using daylight rules of thumb, or we can do that in a much faster way. Like I'm showing with in a project for the Housing Fund in Slovenia, using the urban modeling interface. And, and daylight needs to come in the beginning because it depends on climate and depends on the context, natural or built, and afterwards what we do inside the building. So in this way, we can also understand the impact in our design, but also the influence that we have on the surrounding as responsible designers. And we can do that using the chart that you can see with the, on the one side showing the buildings and on the other y-axis showing the performance of continuous or spatial daylight autonomy. And so we can test window-to-wall ratios, see how the design interacts, and also maybe for a master plan have the whole average spatial daylight autonomy for the whole buildings and track how our design options are going forward. And then when we go to whole building daylight analysis, we need really to know what we're doing and have results that we can trust. So using validated software like VELUX daylight visualizer that can also handle large beam models is important. And also assigning glazing properties, beam models have technical issues that usually for daylight we need to, they have solids, but for daylight we need only one single surface, or but we can also assign that with, it's kind of solved in the software. And so then we can, maybe if it's a single unit repetitive, and we can use that for more analysis. So does it make sense to use daylight metrics for one single unit? And my point of view is that it is, because if you're going to stay there for 8 hours or more in a day, it has a bigger impact on our health than just 1 hour of exercise indoors or outdoors. And also using sections to evaluate the performance and how the daylight is inside our buildings, not just on the floor plan, because our interior spaces of residential or offices, they have different requirements, and we can also see the light shelves or the shadings, how they are performing, also at the vertical eye level, not just on the floor plan, so it matters. We've had for many years now something called level of development or level of definition in the UK when working with building information modeling methodology and management. And in Europe, this is kind of a surpassed approach. We have a new standard called level of information need. And it's different. So in the previous UK standard, we would have levels from 1 to 7 that were relating geometrical and information to the beam models. And this was a too generic approach for the purpose, and also not good for building performance simulation. So, and this new level of information need, it starts with the purpose. So for what do we need to specify, who will be doing it, and what information is to be produced. And also it has 3 parts: geometrical, alphanumerical, and the documentation. So how are we going to communicate the results? And so I'm just showing a simple model. So we need a more detailed model of the space, but we need a larger context that is more generic, not so detailed, for faster simulations. And also to choose the metrics, the sky model, climate data, materials. And this new framework to define the quality, quantity of information requirements aligns much more better with building science and performance simulations. And so now I want to present some new ways of using the European daylight standard based on building on top of it. So, and the standard takes, it's good that it takes a very holistic approach. So for sunlight provision, it's based on the daily, it's not moving, daily sunlight exposure. And then for daylight provision in the interior, it's based on illuminance or the corresponding daylight factor. And for glare with a daylight glare probability, and the quality of view out with some different ways, like width of view, outside distance, quality of information, and the numbers of layers seen. So the first, for the sunlight provision, we can do with tools like Ladybug, sunlight hours analysis on a day from 1st of February to 31st of March, as the standard recommends, and categorize these results to with a minimum level, for example, the image on the middle, or incorporate the 3 levels of assessment in one single visual to communicate the results. And at the same time, we can extract the area of the facade, so the envelope performance of each level of the standard, and also maybe turn it into a percentage, because we don't need data for the sake of data, but we need to actually improve our designs. So using the tool rather, the standard as a design tool rather than an assessment method useful in early stages, and maybe thinking how we can provide maybe to not just the exposure, but maybe also organizing units on 2 levels. So we can provide higher levels, or removing the facades and working with the massing and so on. After that, it was interesting for an office. We were working at Arco to test all the metrics. So this space has dimensions of 90 meters length, 25 meters width, and 3.5 meters high, and with spacing of the supporting columns every 1 meters. Almost a glazed facade, around 60%. So on the top there is the useful daylight illuminance, and it's a very good metric in the sense that when we go hunting for light, we get 3 metrics that we can see: the useful range, the low, and the upper. When we use the daylight autonomy, because it's only for daylight sufficiency, we also have to use the annual sunlight exposure. And we can see that the 10% of the time contour lines of the UD above 3,000 lux are comparable with 250 hours of ACA. So, or all the 20% of time of UD up are comparable with more than 1,000 hours of annual sunlight exposure. So maybe we wouldn't need, and it's also better for parametric studies and generative design. And then it was interesting to run the daylight factor and also the illuminance with the second method of the standard, using daylight hours, not occupied hours anymore. So we can see that the design is not compliant for the values for Finland. If we use the whole floor area, only if we remove the core area that we see highlighted in the third image, the design is compliant. And if we use daylight hours with illuminance, still the design is compliant. So if we, and then since these metrics are computed spatially, we can see that there is a 37% difference in results for the spatial daylight autonomy and the daylight factor target of 300 lux. And with illuminance levels, we have a 25% difference with the daylight factor, and between using the illuminance levels of the standard and the SDA, so there's a 12% difference. So it's not the same using occupied hours and using actual daylight hours. And my question is better to use occupied hours or daylight hours? There are some cases where maybe we would need occupied hours from a certain range, but daylight hours has the advantage because first is based on natural provision of daylight, and the second is our buildings are becoming more flexible, so we are not at the office all the time. We are working with flexible hours, and that changes how maybe also how we should evaluate and understand the performance of our buildings. And finally, I wanted to touch the quality of views based on the standard, and it's something that it's easy to do with tools, and so we can turn that from a graphical method of the standard using floor plan and section to understand the performance. We can turn just for a pointy space, we can turn it to a real-time spatial assessment because geometry-based. So the horizontal site angle is computed and can be categorized the results. We can see it on the left. We can also make the analysis for the layer scene, so the sky, the ground, and the landscape, built or natural. And we can also, at the same time, when we do this, we can also factor the view axis, since it's geometry-based, based on obstructions in the interior or the view opening. And this is very, very important and very relevant when we take on a computational approach and building on the standard. And when we do the point of view-based distance, so in the standard, the distance is facade-based, but when we actually see, if we make take a computational approach, we see that we have a below minimum because of the obstructions, we have high level, medium, and there is no low level. So it changes with the position, it depends on the position in the space and the direction of the viewer. And we can also combine this into one single map, colored map. So we can understand the implications of design early on and the influence that it has on the design. And we also have to understand the limits of metrics. So, for example, the layer scene, we could see the 3 layers if in a low-rise building, but if we are in a more densely built urban context, the lower floor levels would not see maybe the sky, or the higher levels would not maybe see the ground. So it's something that we need to understand, a limitation of the metrics. And we also need to avoid our own bias sometimes when we use these tools. Like we saw previously, with the daylight factor, we would think the design is not doing good, and we would have to provide a higher window-to-wall ratio, and it will also increase energy requirements for the building. But in reality, if we take a climate-based approach, it's much more accurate, and even for a Nordic climate, where we think that maybe the daylight factor is still a valid approach, when in reality both methods using the American way that is in standards in LEED or WELL, it's different, and also using the European illuminance levels is different. Back to the slide. So in the condition of having so the limitation of metrics. So because the condition of the view, the quality of view depends also on other factors, on noise privacy, thermal comfort, something to gaze. So we also need to be aware of the limitation that the metrics have, but also since the standard talks about also the quality of environmental information, but this is not computed, we can do that with very easily with computational tools, add things that would reduce the score or add elements that would increase the score. So, for example, art, landmark, or natural values. And we can also turn it into a spatial metric, so the percentage of space, but it's very hard to say what is good then, because we have a myriad of real-world possibilities when it comes to views. So, to conclude, daylight is a complex task, and we need the right level of information for the model, to run analysis, and also to communicate our results. And we need computational thinking and tools based on our design intent, and we can build these things ourselves. This may not come from commercial software. The standard has been out for 2 years, and there's no commercial software that can do many of the things that I presented today, and also the other speakers. And we need to be enabled by technology and going beyond limitations, avoid our own bias and bias of tools, and use the standard EN 17037 as a design tool rather than an assessment method, and balance in optimization of daylight performance, comfort, and quality views. So thank you for your attention.